Okay, so I'm going to take you through some practice equations. You can write these down. You can try this number one on your own before watching the rest of this. So I'm hoping that you understand how we are in this section 5.4, how we're able to use inverse operations to be able to solve equations. So for number one, we will get rid of a radical, the square root by squaring, but we do not want to square first. Okay, you do not want to square when you have terms over here. Okay, this would be a nightmare if I correctly square. So what you're going to end up doing is just sending this over. Since it's minus, I'm going to keep the root 23 minus 2x on the one side, and then I'm going to go and add, I'm going to pick up this whole thing, send it over to the right hand side. Okay, so if you do that, then this is a very easy problem, because what we're going to do is to get rid of the radicals, we square both sides. So when I square this side and I square this side, the radical disappears. So you're left with 23 minus 2x equals x minus 4, and this is super easy to solve. So if I get my x's together, if I bring this x over, I'm going to have negative 3x. And if I subtract my 23, I'm going to have negative 27 on the right. So one last move is to divide by negative 3, and I get an answer of 9. Okay, and it checks. You can plug in a 9 here, and when you calculate it, it's going to be 0 equals 0. Okay, so if you see a problem like that on your test, make sure you send this over before squaring. Okay, it'll work out nice and neatly then. Same thing for number 2. I am going to undo square root by squaring, but we do not want to square right away. This side would be very messy if I square. You're not allowed to just square the individual terms. Okay, so what you need to do is get rid of this 3. I can subtract 3. Okay, so it's going to be b minus 3 equals the square root of 5b minus 15. Okay, so now this is something you saw in big ideas. This is something that you have to force yourself to understand this. We are now going to square both sides, but since these are terms, I need to take b minus 3 times b minus 3, and I must do that correctly. Okay, we must do FOIL on that. So I'm going to show that I'm going to square this, and I'm going to square the square root of 5b minus 15. So on this side, if you can't do this in your head, you must write it off to the side and take b times b, which is going to be a b squared. This and this will add up to a negative 6b. So outside I get a negative 3b, inside I get a negative 3b. Together is a negative 6b. And then negative 3 times negative 3 is a positive 9. Okay? The right side's really easy. I drop the radical. Now it's quadratic, and I'm going to have to get 0. So I want all this to be transferred over to the left side. And when I do that and I clean this up, we should be left with an easy problem to factor. Okay? It shouldn't take long for us to find the pieces to this. And because it's nice, I don't need the AC method because there's no number in front of my squared term. It's just a b squared. So when I factor it, it's b and b. We know it's minus minus, and I'm going to have to come up with a combination of two numbers that multiply to give me 24. But I also have to keep in mind the outers and inners also have to agree with negative 11. Okay, so when you think of all the ways of getting 24, you may think of 6 and 4, 2 and 12. You will eventually come upon an 8 and a 3. Okay, so if these are the factors, a positive 8 and a positive 3 are my solutions. Okay, so, and both are working. So I do warn you about extraneous solutions. Again, you're not going to lose any points if you miss an extraneous solution. But both of these, you can plug in an 8, you can plug in a 3, and you will get true statements. Okay, now the last two, these are all about inverse operations. Okay, so when I see number 3, I know it's going to take 3 moves for me to get the answer. Okay, I need this all by itself. So the first move is to subtract a 3. I don't want that plus 3. I can simply subtract it. When we subtract it, we're going to get 2,048. Okay, and then you're still left with a 4 n raised to the 3/2 power. Okay, that's an ugly 3/2. So that's a 3. So then the next move, my second move, is to divide by 4. So I must divide by 4. So I already have this on my calculator. And then I divide by 4, I get 512. And then the final move is to undo the 3/2 power. So we learn to undo a power, we raise it to its reciprocal. Okay, so if I want this to just be an n, and that's my ultimate goal, is just that n equals a number, I must raise it to the 2/3. Because if you multiply power to power, we multiply, that's just a 1 then. Whatever I do to one side, I must do to the other. So here's my calculator. You can see I have 512, and I just need to raise it to the 2/3. And it tells me 64. Okay, and I promise you, you plug in a 64, 4 times 64 raised to 3/2 plus 3, you get a balanced equation. Okay, so then what you need to notice, and some students struggle with this, the next problem, I can't subtract a 5. I can't divide by -4. I have to get rid of the power first. Okay, the first step, because it's a whole quantity. Now, if I had something else, like if I had a plus or a minus something, or if I had a number in front, then I would undo what's outside the parentheses. But since there's nothing outside the parentheses, my first move is to raise to the 2/3. Okay, so again, you'll need a calculator for that. I don't expect you to know what 729 raised to the 2/3 is. But the calculator does, and it's nice enough to tell us, hey, that's an 81. And the good news is the parentheses are gone. So we got rid of this exponent. It becomes a 1, so the parentheses can be dropped, and now I have a 2-step equation. All we have to do is subtract a 5. When we subtract 5, we get a 76. And then the last move is to divide by -4. And when you divide by -4, you get a nice answer of -19. Okay, so again, there's just 4 more examples. You have that one paper that you should be able to justify all the answers. So I had the answers at the bottom of the one page, but you want to go through the steps. You want to talk yourself through how we can justify those answers. And again, it's all about inverse operations. So between the paper, big ideas, you have plenty of problems where you should be practicing solving equations by inverse operations. So hopefully this video helped you. These are 4 good examples of what you can expect when I eventually give you a test on this. So thank you for watching.